morning, students. Today I will discuss the AC circuit containing inductance and resistance, for which I have made a diagram here. If E and I be the instantaneous value of EMF and current in this LR circuit, and VL and VR be the instantaneous values of the voltage across the inductor and across the resistor respectively, then we know that VL is equals to I XL and VR is equals to I R, where XL is equals to omega L. It is known as the inductive reactance of the circuit. We want to find the relation between E, VL and VR. So I have drawn a phasor diagram here. As we have discussed in previous videos, then that when AC flows through a resistor, then the voltage and current are in phase. You can see in this diagram, this voltage VR and I current is in phase, means they have no phase difference. And we have also discussed that when AC flows through an inductor, then there is a phase difference of pi by 2 between current and the voltage. So this phasor VL is shown here, leading I by a phase angle pi by 2, and it is represented along OY. If OA and OB represents the magnitude of phasor VR and VL respectively, then OC, the resultant of OA and OB, represents E, and this can be calculated. OC is equals to under root OA square plus OB square, or E is equals to under root VR square plus VL square. On substituting the value of VR and VL, we get E is equals to under root IR square plus IXL whole square, or E is equals to I common, it is under root R square plus XL square. From here we can write I as E upon under root R square plus XL square, or E upon under root R square plus omega square L square. It can be written as equation number 1. Now the effective opposition offered by the series combination of L and R to AC is called impedance. Here this can be written as I is equals to E upon Z, where this Z is known as impedance, and it can be found by this formula, and it is known as impedance. This equation gives the value of impedance in case of a LR circuit. From the phasor diagram, it is clear that the EMF leads the current by a phase angle phi. By using this right angle triangle OAC, we can calculate tan phi is equals to AC upon OA, or it is equal to VL upon VR, and VL is equals to IXL and this VR is equals to IR. So the value of tan phi is equals to XL upon R, or phi is equals to tan inverse XL upon R. This is the phase difference between EMF and the current, and in case of a LR series circuit, the EMF leads the current by a phase angle phi, which can be calculated using this formula.